And
Oh, awesome. All right, so we're going to do number 5. We can see the answer is 4, -3. But let's take a look at it, and we'll do it kind of step by step. Whoop, a little too far. Grab the hand, slide back over. There we go. Okay. So in number 5, our points A and B. A is the point 1, -3. B is the point 10, -3. So we know this is what kind of line? Horizontal. Good. Makes a horizontal line. We're finding a point P so that BP is 2/3 the distance from AB. Alright, so we could find vector AB, and to go from A to B, we need to move 9 units to the right and up and down 0. Now we want to go 2/3 of that distance. So 2/3 of 90 is 60. But this is BP. So it's not from point A. This 2/3 is from B. So we're going to have to do B minus that 2/3 vector AB, which in our case, B is the point 10, -3, and we're going to be subtracting that. So we get the point P is 4, -3.
that's why I would only get the Y part right.
Yeah, number 2 did that too.
Yep.
So when you found 5, 6, you had to subtract it from B. Okay, now, what I'd like to do now is go over number 7 and then have you retry number 8. So, number 7 is interesting because what we're missing is point B that's somewhere down here. So we can't even find vector AB. We can't go all the way from here to there. What we know is AC. So we know this vector. We know, or we can find, the vector that takes us from here to here, right? So we know that vector AC is 0 from A to C down 10. Well, it tells us that AC is 4/5 of AB. So could I write this math sentence? Vector AC is 4/5 of AB. Is that fair? Okay. So we know vector AC is 0, -10. And how do I solve for vector AB? Right now, vector AB is multiplied by 5/4. So if I do the reciprocal, 4/5. So if I do the reciprocal, I get 5/4. And so that gives me 0. And so that would be -54, which is -25/2, which is 12.5. Vector AB is -12.5. 0, -12.5. So if I took A and wanted to get to B, and I know vector AB is this, all I have to do is take point A, which is the point 4, 16, and add the 0 and add the -12.5, and so we would get that point B is the point 4, 3.5.
It's easier when you do it first round.
Okay. Now, I want you to try number 8, but before I let you start, I gave you BC here and AB here. So,
Oh, so you just subtract.
think about if this is 4/5, what is the other? 1/5. Okay, start it. You try number 8.
Oh my god.
I said.
No one got it on 4/5. The other one is 5.
I was working with them and I didn't get it.
What else were you saying? 5 under 1?
Since we're here to have a clarifying Tuesday.
Not 1/5.
Would you call those two as the dancing princess? Mine does.
I'm like, how's it?
I don't know why.
It is a lot.
When would you like me to?
It's enough to keep you busy for a full class period.
15th day. Wait, what's like a little marked out by A? When should I like show this to you on Friday or Thursday?
Friday's okay.
Friday actually.
That's okay.
Wow, it's so short.
15 comment 9.
Damn.
The answer is 4 comment 8.
I know.
Are we going on 7 or 8?
You're supposed to be working on 8. We just did 7.
Oh, fine.
Oh, does that mean when
No, that's my I thought we were
So do you recommend drawing the lines?
I like it. It just makes things make more sense to me.
I'm looking at this. It's 15 times 5.
Yeah.
Oh, we played Kahoot, didn't we? Not too long ago. I remember. I do have a bunch of radicals on my paper. The radicals aren't parts. Something, Oh my god. I was smiling and I put me down and I hit my gum on the then
Oh, I've heard it.
The red brain.
I only missed it by one.
Oh, you need the math roll again? That was right.
Oh, you did get it right.
Told you.
You did get it right.
Alright.
Oh,
So there it is. Nice and boxed in pink.
Oh, I
So
got
if BC is 4/5, then AC would have to be 1/5. So AC is equal to 1/5 vector AB. Vector AC is 3, 0. So when we multiply by 5, we get that vector AB would be 15, 0. So if we take point A
What?
and we add the components for the vector AB, so we add the 15, we add the 0, we find the other endpoint, 18, 9.
I said 5.
It doesn't make sense though.
Would always work.
Yes, ma'am.
There's one situation
So like, I
I
did, like I got the same answer, almost, I got 18.5 for some reason, cause I found that, I don't really know how to explain it, but then I did it backwards, so I used the C equation, or the C6-9 coordinate, and I got, I don't really know how to explain it.
I'll come look at it.
Okay.
Okay. Let me get through the lesson and then we'll come back to that. I'll come help you. Or verify that you're right.
It's a starfish.
Oh, here's all of today's lessons. And they're gone.
Well, I don't know what that. Okay.
Okay. Alright, so this is right below your warm-up. It's today's notes. Today we're revisiting parallel and perpendicular. I know you've studied parallel. Perpendicular may have been new, but it was under summer work. So it was something that I required you to look over this summer and be familiar with. So let's graph these, and then we're going to readdress some of the things you've already learned about parallel and perpendicular lines. Okay, so I would like you to go ahead and graph these three here, these two here, and these two there. So it's going to take you a few minutes. Everything's in slope intercept. Even if I switched up the slope and the intercept, nothing is in point slope. So
Well, I didn't get one of those.
We have to connect the dots with online.
You should connect it with the
that means tomorrow 2 of my Algebra 2 students will come in with that. And both of them will tell me they don't understand. Because they picked up y'all's worksheet.
Like, you should tell them, like, wait, you didn't understand? Like,
Yep.
you should play with them a little bit, and at the end of class,
I
be
thought
like,
that's in class. Were you not listening?
I know.
Wait, where are we supposed to grab
I'd be a terrible teacher if I did that. You guys need to listen.
We would just be the teacher.
Sam graphs though. We could graph those.
Of course you did.
No, I did not.
What'd you say?
I didn't say anything.
Don't graph with the calculator.
It's already gone away.
They'll never.
Oh, hilarious.
No, well, he doesn't even know.
You don't have to erase it. Just do the rest of them by hand, okay?
I grabbed all
so
3. Okay. So wait, you want to graph them all in the same line?
Yes.
I heard you were loud.
What?
Good night, good.
Dedicated member of the wrong. Is this what yours looks like? They're using your paper.
To write to. I can't
What?
speak English. Are you keen? Then you remember that one thing?
Oh, yes.
What do you want, Joe?
Do you remember that one thing?
What?
Are you keen?
Day and night.
Jesus. Oh, we did mess up.
Oh, it didn't?
No, it's completely on the line.
That's cool.
Yeah, that's cool, so don't touch me again.
Oh my gosh, I'm sorry.
I said don't touch me again. Punch me, literally, like, hitting my head.
Wait, which other ones do we grab?
All of the ones that I asked you to graph.
I saw, I just forgot.
Oh well, sounds
I
like a
just want to make sure I
problem.
did it right.
Okay.
And these
all
two.
Your graphs
And
should
these
be
two.
sorted.
Okay.
You got
That's
the
what I
news.
thought, but I wasn't sure.
Well, you better be sure next time, 'cause she's
What do you
Why is he
do?
yelling at us?
Okay,
He's annoying too.
Stop.
You're annoying.
Sweet.
Did Austin not do that?
Like, I don't know if it's
Go back.
Whatever.
We play in Spanish.
We're not in Spanish.
Does it matter what class you're in? It doesn't. I'll say in English, just spell it. I literally just said her name. I just said it. Aren't you listening,
What
Angie?
is life?
Stop.
You haven't lived if you haven't had to
Happy birthday, Zoe.
You haven't lived. That's only 3 years ago.
Read that, Brett.
Wish for that to somebody.
My birthday never. I just want to be July 5th, 2001.
July 5th? July 6th. Okay.
You came down for having the same exact birthday.
Yeah. It's still July, but you complained about July 5th. Try winging an extra 24 hours. Still a little bit, okay? That 24 hours is the longest 24 hours.
I wish I was born July 4th.
I wish I was born on New Year's.
Anything? No. Anything before 1766.
Okay, it sounds like we're done. So, in part A, if we look at these, all of these are parallel. And what do we notice that's the same about them? They have the same slope. What's different? The y's intersect. So lines that have the same slope are parallel. Okay, on B, what we should have noticed is
Stop.
these two are perpendicular and these two are perpendicular. So perpendicular is telling us it's forming right angles. So when we look at the slope here, and we look at compare this slope with this slope, what do we notice about the slopes? They are opposite signs and they are reciprocals. So that's the big takeaway. On this section, we need to know that parallel lines have the same slope and perpendicular slopes, the slopes of perpendicular lines are opposite reciprocals.
Oh my Lord, today's Tuesday.
Okay. So, if we look at this, the slope of this line is 3/5. So a parallel line, what would the slope be? 3/5. And a perpendicular line would have a slope of
Negative 5/3.
Okay, number 7. The slope of this line is -3. So a parallel line slope would also be -3. The slope of a perpendicular line, though, would be +1/3. Yeah, there's not enough room to write it straight across, so I'm going up and down. So this one, oh yeah, I see what you're saying. I didn't quite write it in slope intercept form. I put the intercept first. I wrote it in intercept slope form. And then the slope second. Alright, so a parallel line would have a slope of what for number 8? 1. And a perpendicular line would be -1. Because when we flip 1, we still have 1.
1/1.
The reciprocal of 1? Yeah. Alright, 9. A parallel line would have a slope of 4. A perpendicular line would have a slope of -1/4.
All your stuff are simple plus, right? Dang it.
Okay, number 10. Number 10 is in standard form, ax plus by equals c form. Now, hopefully you remember from way back, the slope is always going to be the opposite of this coefficient divided by that coefficient because that's what happens when we solve for y. We get -a over b. The y-intercept is always c over b. So, the slope of this line is -5 over -2. So the slope of that line is 5 halves. So a parallel line would have the same slope. And a perpendicular would be the opposite reciprocal.
Wait a minute. She said 5/2, but it's the opposite. Why?
Opposite sign and reciprocal.
Jesus. Jesus.
Okay, so down here we're referring to these problems right here. So when it says parallel to number 6, it's talking about parallel to that line. Okay, so in this section it brings back something else that was on your summer work. When you're given a point and a slope, what do you use to find the equation of the line? Point slope. That is correct. Okay, so number 11. They're giving us a point and they say it's parallel to number 6. So all we have to do is check out number 6. Parallel, the slope is the same. So the slope would be 3/5. The point is the point 6, -2. So point slope is y minus y1 equals m times x minus x1. Okay, this is the transformational form of a line. Just like last year, you remember when you did quadratics and you had the h and the k and it shifted it up, down, left, right? This is that shifting form. Shifting, shifting. So when you first studied point slope, we didn't talk about it that way, but now we know about transformations of functions. So when we plug in, we get y plus 2, 3/5 x minus 6. So we get y plus 2 equals, we're going to distribute here, and then we'll subtract 2. So 2 is 10/5, so that makes 28/5. Yes, Brock?
Isn't it a lot less work to write an equation and solve for B?
Eventually we're just going to leave it in this form. And you've got to be able to operate in point slope form in every class above here.
So I shouldn't just plug it in.
Yes, ma'am.
Alright, so the number 11 where it says y minus y1, what's that equation called?
This is called point slope.
So what's the normal one? Point
Slope intercept. Slope intercept. Y equals mx plus b. This is slope intercept.
And the other one's standard.
And the other one is standard.
X plus by equals C.
Okay, so this one's standard. Yep. There we go, all three. Right there, on one little notes page.
And that's point slope.
And it's going to be on the website.
It will be. Alright, so number 12, we want it perpendicular to number 8. Perpendicular is a slope of -1. So our slope is -1. Our point is the point -1,5. So this is not going to be a fraction. It's going to be much nicer. Y minus 5 equals -1 times x plus 1. Because minus a negative makes 2. So we get y minus 5 equals -x minus 1. So y equals -x plus 4. Okay, you try number 13.
I think it's pretty cool how it changed it. It's interesting.
I like how it's just
Adding, subtracting, and multiplying can do all things. You tried number 13.
Yeah.
I can do number 13. Alright, what was the slope again? Oh, it's 9.
Oh my gosh, I don't even have to.
Oh my gosh, like, on
I
it,
don't even have to do it.
One and 5.
is negative 3, so if we're doing parallel, my slope is negative 3, my point is 0, 9, which is the y-intercept. So I can go with this form, can't I? So I get y equals negative 3x plus 9. What do we notice about this and this?
It's the exact.
It's the same. So, when the slopes are the same, they're either going to give us parallel lines, or if this is the same line, what do we call that word? What's the special word for the
Congruent.
same line?
Oh, coincidence.
Coinciding.
Coinciding.
Did you say coincidence?
Okay? So these are coinciding lines because they're actually the exact same line. So either they're going to be parallel or it's going to be the same line. Alright, so your homework is out of the coordinate algebra book. This is the one you have not been assigned. But they moved this material into geometry. And let's talk about why. Okay? Because what we're doing is we're doing geometry in the coordinate plane. So what we're going to move to tomorrow, and some you're going to think about tonight, parallelograms. Opposite sides are parallel. How can we prove that? Slope. Okay? So that's where we're moving with this. Alright, so those of you that are still struggling to open the textbook online, I got you covered. I copied all the problems into my notes, and they'll be posted to my website. Okay? So we still have 5 minutes of class. If you'd like to take pictures of these pages, you can do that now. I'll go through it slowly. What you cannot do is talk.